In this video, I'm going to explain you privilege escalation techniques on Windows systems. So, what is privilege escalation? Why do we need it? In simple words, privilege escalation is a process when an attacker tries to elevate his access rights. As you know, on one Windows machine there can be several accounts but with different access rights. For example, one account can install any program, but other accounts cannot. There are two types of escalation. In vertical escalation, attacker elevates his privileges from lower to higher. For example, from standard user to administrator. In horizontal type, attacker also uses resources on behalf of other user account, but in this case both accounts have the same privileges. Now let's consider some methods which can help attacker to elevate his privileges. In this video, we will review only 4 techniques, but there are a lot of other different methods. The methods we are going to review are still actual and perfectly work on Windows 7 and 10. It sounds strange, but on some machines credentials are stored in text file and registry. Credentials can be kept by user or domain administrator. It is recommended to check the following folders to find useful information. But of course, the password can be stored in any directory of the system. To find credentials, you don't need any special exploits. You can use built-in CMD commands, but it takes some time to filter obtained results, or you can write a simple script to simplify your task. The next method is based on registry settings. Normally, due to security policy, program installation is forbidden for standard users, but domain administrators can allow installation of Windows products which are provided with Microsoft Software Installer packages. These files have MSI extension. If domain administrator changes the settings in both registry hives, all standard users will be able to install MSI packages with system privileges. And of course, this feature can be abused by attacker, and specially crafted MSI file can be launched. Please remember that given registry hives do not exist on Windows machines by default. They are set by administrator manually. So, when you perform a penetration test, you can check registry settings using the following commands. If you get such result, you will be able to gain system privileges. Otherwise, you will get error message because requested registry hive do not exist. By the way, Metasploit framework has exploit which can check registry and generate crafted MSI file. The first 2 techniques we discussed now are related to human mistake. It is not vulnerability. The next 2 methods are based on vulnerability in system and user applications. Let's consider DLL hijacking. We already considered this type of attack in details in client-side attack section. As you know, any Windows services or applications for their normal operation can load some DLL files from predefined location. But if required file is not found, the process tries to find it in the following directories in the order which is depicted on the slide. Attacker can place specially crafted DLL file in one of these folders. If the process which launched attacker's file is running with high privileges, the child process will inherit the same privileges. It is also important that current user account must have appropriate permissions to modify files in one of the listed folders, because we need to place malicious DLL file. So this is the basic idea of privilege escalation with DLL hijacking. But how to find vulnerable services? You can use Process Monitor tool from sysinternals. Look at the picture. The process tries to find missing DLL file in different locations, including this directory. And as you know, this is potential vulnerability. The next step is to check whether the user account has rights to modify these folders. This can be done by 2 ways. By means of access check tool from sysinternals and with built-in CMD command. If the findings are positive, attacker can create malicious DLL file with the same name of missing one and place it to the corresponding directory. Now let's review another technique which is called UAC bypass. UAC stands for User Account Control. It prevents system from unauthorized changes which can be done by users or malwares. UAC notification prompts every time when privilege evaluation is required to perform some action, for example, software installation. Okay, we know what UAC is, but how to bypass it? UAC can be bypassed if malicious process is launched by trusted legitimate Windows service, which is running as system. In this situation, the child malicious process inherits the same privileges of parent process. There are some Windows applications which can automatically elevate their privileges by passing user access control. And it doesn't matter which type of user account launched these applications. So if one of listed programs runs malicious file, the created process will have the same privileges. It looks good, but it works only under certain conditions. User account must have medium integrity level and must be in administrators group. The parent application must be able to automatically elevate its own privileges. The attribute auto-elevated must have value of true in manifest file. Also, given application must be signed by Microsoft and be in trusted directory. Let's try to get information about user account. It can be done by built-in cmd command. As you can see, user account meets the conditions. Now we need to check self-elevated applications. The best tool is SysCheck from sysinternals. It provides complete information we need. After we discovered that a remote system is vulnerable, we can create malicious file to be launched by Windows application, or we can use exploits in Metasploit. Most of them work good on Windows 7 and 10. When you already know the theory and purpose of privilege escalation, let's do some practice. In this video, we will review two techniques, DLL hijacking and UAC bypass. To elevate privileges, Meterpreter has a special script which can be launched by command get_system. It uses 4 different techniques, but unfortunately, on modern system the script doesn't work properly. That is why we need to use a special exploits. One of these exploits we will try right now. Let's switch Meterpreter to background. Now enter the following command. Check the options. I already set required options and we need to set session option, which requires the number of Meterpreter session. When we run exploit, a new Meterpreter session will be established. We don't need to set payload, it will be set automatically. By default, it is Meterpreter/reverse TCP, but you can change it with the command set payload. Now let's run it. And we have a new session. Now we can execute the get_system command. Let's check what we have. And we have privileges of system account. If this exploit doesn't work, you can try another one from this directory. Or you can run search query with bypass UAC keyword. Now let's try to elevate privileges with the DLL hijacking technique. To demonstrate it, I'm going to use Windows 7. It contains a couple of vulnerable services, and one of them is Internet Key Exchange. Let's run Process Monitor to find missing DLL. I am going to use the following filter to display missing DLL file. The service will try to load this DLL. That is why I included this name in the filter. Because the Internet Key Exchange service is stopped by default, we need to start it. And as we expected, the service is trying to load missing DLL. The next step we need to do is to check whether current user has permissions to modify displayed folders. Most probably he doesn't have privileges to modify system folders, so we will try the last one, program files /OpenSSH/bin. I'm going to use access check tool from sysinternals. Just execute the following command. And here is the result. RW means read-write permission. So on behalf of current user we can place malicious DLL file. Now we can use MSF Venom utility to generate crafted DLL file and then launch listener. After that we need to start the service manually, or if it's already started we need to wait for system reboot. So the procedure is a little bit complicated. That is why I'm going to use another way. Metasploit contains suitable exploit and we can try it. I ran exploit in background because I'm going to restart Windows machine and I need a handler waiting for incoming connection. Let's restart Windows machine via the first Meterpreter session. Windows machine is running now and we have an active Meterpreter session with elevated privileges. As I mentioned before, Internet Key Exchange service is stopped by default, but it can be started by any standard user who is the member of administrators group. So if you find this service running, you can try given exploit. Of course, there are other vulnerable services and you can make research at your own using Process Monitor tool.